Good day out there, viewers. I'm welcoming you to part 2 on chemistry subject, where I will be dealing with redox reaction. This part 2 will be separated into 2 sections. The A part, or the section A of it, will be how to identify oxidizing and reducing agents in a redox reaction, while the second part will be how to balance redox equation. First and foremost, redox reaction means a reaction during which both oxidation and reaction are taking place. It is important to note that neutralization reaction, that is the reaction between an acid and a base, is not a redox reaction. In my previous video where I treated part 1, that is oxidation number, please, it's important you go back there to update your knowledge before you go through this one. There is something I will involve in this case that was not mentioned in part 1 when I was treating oxidation number. Now, these are hints that you need to absorb. Please take note of that. At the end of watching this my video, if you are impressed, please do not hesitate to subscribe to my channel for subsequent notification, and as well like the button and share. Alright, oxidation can be defined in terms of oxidation number as increase in oxidation number. So if oxidation number of a substance is increasing from left to right, that is from the reactant side to the product side, it shows that process is oxidation. While the oxidation number, when it decreases from left to right, that is from the reactant to the product side, it shows reduction process. During oxidation, any substance that is oxidized is called reducing agent. Please take note of that. And of course, any substance that is oxidized means is the substance whose oxidation number is increasing, and such a substance is the reducing agent. While during reduction process, a substance is reduced, and that substance that is reduced is called oxidizing agent. A substance that is reduced is the one whose oxidation number is decreasing from left to right, that is from reactant side to the product side. Please take note of all those information. They are crucial for your understanding. Then, both oxidizing and reducing agents are always found on the reactant side. So that means if you want to identify oxidizing agent and reducing agent, you don't need to look at the product side. Both of them are always on the reactant side. The following examples will throw more light on it. But do not forget, you need to update yourself on oxidation number before you can watch this video. So I will advise you go back to my previous video on oxidation number before you watch this one. Thank you. Now, these are the questions we want to treat to cover this topic: finding oxidizing and reducing substances in a redox reaction. So I'm going to deal with them one after the other. Please, if you want to have a try of these questions, please go ahead and do that. Now, let's have a look at the first equation of reaction. Copper reacting with nitric acid to produce copper 2 triazonitrate fine. water and nitrogen 2 oxide. So this is the reactant side. This left side of the arrow is the reactant side, while everything on the right side of the arrow is product. So like I told you, the first thing is try and identify how the oxidation number is changing from left to right. That's the first thing I'm going to do. This is copper atom. This is one of the points I said I did not mention in my previous video when I was treating oxidation number. When you see an element, an atom of an element on its own, existing on its own in a reaction, the oxidation number is 0. Please take note of that. When you see an atom of an element standing alone in a chemical reaction, its oxidation number is automatically 0. Now, oxidation number of copper here is 0. Hydrogen has +1. Oxygen has nitrogen has +5, while oxygen has -2. But you might not mind yourself about nitrogen being in the middle. You are conversant with hydrogen and oxygen, so let's limit ourselves to that, so that it will not be as if, how do I know that it's +5? So oxygen is -2. All right, let's now come here. This is copper nitrate. So definitely, once is in the compound, that means copper has +2 as oxidation number, while oxygen is still what? -2. Hydrogen +1, oxygen -2. Nitrogen, don't really bother about that. All right, now it is obvious that copper has increased its number from 0 to +2. How do I know that copper is having +2 as oxidation number? Because of these two at the end of this bracket. That is copper 2. Okay? Therefore, copper to this place is oxidation process, because the oxidation number has what? Increased. So if you now look at this one, so if oxidation number has increased, that means this oxidation process, and that means that copper has been oxidized. Therefore, copper is oxidized according to the note I wrote on the board at the beginning of this class. So since copper is oxidized, it shows that definitely copper is what? Reducing agent. So this is our reducing agent. Okay? Now, let's take note of this again. Copper has increased from oxidation number from 0 to +2. That means this copper has been oxidized. And whatever is oxidized is the what? Reducing agent, according to the note I gave. So definitely you don't need to bother yourself about how to identify oxidizing agent now. Since on the reactant side we are having two substances, copper and nitric acid. And since copper has been identified as the reducing agent, automatically HNO3, which is a nitric acid, is what? Reduced. Therefore, HNO3 is the what? Oxidizing agent or substance. That is it. So once you identify one, this other will show up. So copper has been identified because it has been reduced. It has been oxidized, from 0 to +2. That is oxidation, increase in oxidation number. And oxidation process shows that this substance has been oxidized. I told you in that note that look for your oxidizing and reducing agent on the reactant side. It's not on the product side. So since this one is now is the reducing agent, definitely this one is what? Oxidizing agent, which has been reduced. And of course, it's very obvious. HNO3 has been reduced to what? Water and what? Those, it has been reduced to NO. Because there is no nitrogen here again. So you can see it has been reduced. So it is this nitrogen, which I said I don't want to show, is that's +5. So here, that will be what? Plus, yes, +2. Since oxygen is -2, nitrogen will be +2. So you can see that +5 has become +2. That is what reduction. So from HNO3 to here is the reduction process. All right, example 2. This is the reactant side. Since oxygen has negative what? 2. Then what is the oxygen number of this one? That is plus what? 4. How do I know? 2 times -2 of this. If you know how we calculate oxygen number in the previous topic, you find the oxygen number of this one from this, it will give you +4. Then here, +1 -1. If you calculate the oxygen number of manganese here, it will give you +2. And this one is -1. So this one is 0. This one is +1. This one is -2. Okay, now if you look at this, I knew all this by calculating the oxidation number according to the first top video where I treated how to find oxidation number. So that's why I said you should go back there. So you'll be able to know how I got 4 for this, how I got 1, how I got 2, how I got this. And don't forget, I told you at the beginning of this very particular video that when an atom of an element is standing alone, it has oxygen number of 0. Chlorine is standing alone, that's why it is 0. So obviously, from here, +4 has become +2. That is decrease in oxidation number, which is reduction process. Why? From here, chlorine from -1 has changed to what? 0. So that is increase in oxidation, that is oxidation process. So meaning that from MnO2 to MnCl2, that is oxidation. Please take note of that. So Mn O2 to MnCl2. That is oxidation. So from HCl to chlorine, that is this is reduction. While from here to here is oxidation. Yes, reduction plus 4 to plus 2, that is reduction, that's decrease in oxidation number. So definitely that means MnO2 has been reduced. Therefore, MnO2 is reduced. So is the oxidizing agent. Oxidizing agent. Don't forget, anything that is reduced is oxidizing. Why here? HCl is oxidized during oxidation. So that means HCl is the what? Reducing agent. That's all. Okay, the third question. If you use the knowledge acquired in my first video, part 1, finding oxidation number, you will know that hydrogen has +1, sulfur is -2. Then iron, we have +3, chlorine has -1. Iron, we have +2, chlorine -1. Hydrogen +1, chlorine -1. Sulfur, we have 0 because it's standing alone. So it's an atom standing alone, so it has 0. All right, now if you now look at sulfur from here, look at sulfur from -2. Sulfur becomes 0. Is that decrease or increase? -2 to 0. That is increase. Therefore, that is oxidation taking place from H2S. H2S, that's hydrogen sulfide, to sulfur. That is oxidation. Because there is increase in oxidation number from -2 for sulfur to what? 0. Okay, if you now look at iron from +3 to +2, what is taking place there? That's reduction. That means from FeCl3, which is iron 3 chloride, to FeCl2, which is iron 2 chloride. That is reduction. Reduction. So definitely hydrogen sulfide is oxidized. Hydrogen sulfide is, because oxidation, that is oxidized. And whatever is oxidized is the what? Reducing substance. Why here during reduction, iron 3 chloride is reduced, because that's reduction. And whatever is reduced is the what? Oxidizing agent. It's as simple as that. So question 4 is ionic equation. This zinc atom, that means oxidation number of 0. Why is one has oxidation number of what? +2, because of the 2 charges on it. This zinc ion, that is oxidation number of +2, because of these 2 positive charges being carried. And this is copper atom, 0. Don't forget, atom, we have 0. So that means from zinc to zinc ion, 0 to +2, that is oxidation because there is increase in oxidation number. That means definitely from here, from copper ion to copper atom is reduction. So zinc to zinc ion, that is oxidation. That means this zinc on the reactant side, zinc is oxidized. So because of that, is the what? Reducing agent. Anything that is oxidized is the reducing agent, as stated in the note at the beginning of this class. While from copper 2 plus to copper atom, that is reduction process. It is obvious. You can see from +2 to 0, oxidation number has decreased. So that means this copper 2 ion, which is on the reactant side, is reduced, being reduction, and whatever is reduced is what? Oxidizing agent. So I will leave the last question for you to try. If you enjoy this video, please do not hesitate to subscribe to my channel Science Explained for subsequent release of my videos. By God's grace, in the next release, I'm going to section 2 of this redox reaction, where I'll be balancing ionic equation. That is in the redox reaction, where we are going to have simple and complex ionic equation. Until then, see you.